Hey everyone, welcome to this session by Intellipaat. In today's session, we'll be comprehensively learning about Numpy. Numpy is a very powerful Python library which is used to perform various numerical computations and logical operations on multidimensional arrays. And before we begin this session, make sure you subscribe to our channel to stay in touch with all of the upcoming videos that we'll be putting out for you guys. And if you guys are looking for end-to-end course certifications on Python, make sure you check out Intellipaat's website to master the language and earn a certificate in the same. Without further ado, let's begin by checking out this session's agenda. To start out with, we'll quickly introduce what Numpy is, and followed by that, we'll check how we can initialize and inspect a Numpy array. Thirdly, we'll be checking out how we can perform various mathematical computations and operations on a Numpy array. Followed by this, we'll be checking out how we can index and slice an array. And next, we'll be checking out how we can differentiate a Numpy array and a simple list. Followed by this, we have a quiz planned out for you guys. So this quiz is basically to recap all of the concepts that we learned in the video. Make sure you enter the answers in the chat box and to check if you've got the answers right or wrong. And lastly, if you have any comments, make sure to put them down in the comment section below and we'll be happy to help you out. Without further ado, let's begin this session.
We have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array, it is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple. So that's why it is editable. Okay, and numpy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am getting it again and again, pip install numpy. So it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it, we write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it.
Just a quick information, guys. If you guys are interested in mastering Python, make sure you check out Intellipaat's Python certification course. This will help you master the language and let you get in-depth experience about it as well. For details, check out the description box below about the course. And now let's get back to the session.
So now next will be where it is where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by number you are changing yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Next is nd array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? Sorry, so you need to do this, so you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays I will be coming, okay, I am working on 2D arrays, sorry I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names, A and B, right? 2D arrays I will be showing you, not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print all. If we do this, that also will mean the same and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay, now next is if you go into check the individual, yes, right, so it will be begin colon n minus 1, that is how. So right hand side will always be excluded, like that. Okay, next is NumPy array initialization, right? So how do we initialize NumPy arrays? As we have already seen, right, how do we do that, but still this is how you do it. Okay, so initialize means what we want to do is we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing, we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to come on what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in numpy. So what you do, you write np dot zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np dot zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in numpy. So that's how you print zero arrays in numpy. Okay, next is if you want something with the interval, right? So how you do, you write like this, np dot array, within bracket we pass, so it will print you another new array. So what we are doing, we are sorry, in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's arrange, so it's a range actually. Okay, so what we are doing, we are passing three variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having five, we want lists to be five separated, right? So first one and second one difference will be five, like that. So that's how we have, so we have three numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in numpy. So using this a range you can have other type of arrays also.
Just a quick information, guys. If you guys are interested in mastering Python, make sure you check out Intellipaat's Python certification course. This will help you master the language and let you get in-depth experience about it as well. For details, check out the description box below about the course. And now, let's get back to the session.
Now this is the same thing. Okay, now next thing is this a range is done, right? Now let's say we want we want to spread some points over a straight line. Okay, so how do we do it? We want to I mean what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line. Okay, so what we will do then, like we want some points between range a and range b. Okay, so here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise. Okay, we want it to spread along a nine line like this. So between 5 and 10 we want six numbers. It is almost same as numpy, but it has a bit difference. So how it is differing, I will show you. Okay, so
Just
this
one
links,
doubt in the arrange. The last, the end number can we put as 19 instead of 20 in the last example?
yeah, then it will print only single number,
No, no,
right?
no.
And
No, the second argument.
yeah,
Yeah.
this one we can do. It will go till 18 only, not an issue.
Okay, thanks.
Yeah, you can put anything. So the logic is when it reaches the end number, right, with interval, if it goes past or if it goes till the last number, then that number will be I mean that number will be excluded, right? So let's say 18 plus 2 will be 20, right? So 20 will be excluded. Okay, so that's how it works. Okay, so for 19, 18 plus 2 is 20, so anyways 19 will be excluded, right? Nothing is there to print it out, right? So that's up. Okay, so we are not into loops, so I won't go in that. Okay, next is this linspace. Okay, so linspace and arrange, right? So arrange, what it does, it takes in three numbers, so start number, end number, and So what we do in arrange, we have three numbers as a parameter. What we take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals. Okay, but in linspace, what we take three parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there. Okay, number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linspace and arrange, and all these functions we will be using heavily when we use go for data science. Okay, because these things we will need, and you will see how do we do that. Okay, these things we will be discussing when we discuss about the data science concepts. Okay, now next is how do we do array with the same number. Okay, next is how to create an array with the same number. So this is same for same uses, like that, like for zeros, right, for maths, for carving out some masks, like that. Okay, so if you use this keyword, then if you pass some values, so come on, if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up. So np dot pull, it will take up first the tuple of row numbers, column numbers, and it will take up the number to fill that array with. Okay, number to fill, like that. This thing works, this full function works. It can be anything. Okay, it will give you a array full of that kind of numbers of any dimension. Okay, any dimension can be given. Okay, any real world numbers can be given, I mean, sorry, any integer number can be provided as a dimension. Okay, so that's how this full function will work. Okay, next is to randomize an array, again for, I mean, that masking only. So how we do, let's say we want a 3 by 4 matrix to be randomized. So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, in that way it will be organized. So random is this thing. Okay, now we go to how do we access this numpy arrays. Okay, now let's say we are creating two arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do printf, so that's how the shape function works. Okay, that's how we can access a shape of an array. So shape function will return tuple of its row number and column number. Okay, so a dot shape returns tuple row num column, like that. Okay, so it will be returning like this. Okay, now the next thing is, what is the use of the shape function? Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it, and we can change the values. Okay, even now we can access like a, no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is happening? Okay, so we can access individual elements of the shape tuple that is being written like this. Okay, like we use like we access normal tuples. Okay, so we can, what we can do with this a dot shape, we can we can get the tuple, I mean tuple of row number and column number as an output. We can change the change the shape of the shape of the matrix with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all. So that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just, sorry, for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay, one thing, so you guys are acquainted with you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back the zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's going to be
No.
one. Shape is always gives only the columns and rows here. The 0 will give the rows and 1 will give the columns. That's it.
The column. So
Don't-
that is a
you
tuple
don't- you
basic,
don't-
right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
that
got
will be 0 1, like that. So it is an 1D tuple or 1D array, whatever you call it. Okay. So that's
Okay,
how it
thank you.
works. Okay. Now we can have several more examples of NP. This shape function, but I am not going into the detail. But you need to remember one thing: you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3, it won't work because the size of the array is total of 6, right? So we need to have it multiple of 6 only. That's how we can break. That's how we can reshape. Okay. That's what is about this shape function. Okay. Next is how to get total number of columns. Okay, so again I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay, so that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values, number of points needed, will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that, like a shape function. So I will put it right in there, but the only difference, it can be modified. Okay, so where were we? We were with this ndim, right? So how it will work? Ndim will return you the, it is not, it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But ndim will return you the number of dimensions of the array. Okay, so if you see the ndim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2 dimensions, right? So that's what ndim returns. Okay, ndim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So ndim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is the d type. Okay, d type is to give you the type of each elements in the array. Okay, in the numpy array it will give you type of all the elements, and numpy arrays cannot be heterogeneous, it has to be homogeneous always. So numpy arrays will return you, return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this d type function. Next is how do we use it for maths calculations. Okay, so any doubts till this part, till this d type? Now if I show you something more, say Okay, next is as I have created now array with like float numbers. So you see the arrays are the D type is printed as float 64. Okay, so you have you got an array of I mean the D type as float 64. Okay, so that's how this D type function works. Okay, so and numpy, as the name suggests, it is used for linear algebra. Okay, so numpy is used for number mathematics or linear algebra, so you won't be really having string arrays in numpy. Okay, so you won't be having it, that is not provisioned. So numpy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is numpy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this numpy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how numpy summation function works, and it can add up to different things. Okay. Okay, so sum will return you a sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there.
Just a quick information guys, if you guys are interested in mastering Python, make sure you check out Intellipaat's Python certification course. This will help you master the language and let you get in-depth experience about it as well. For details, check out the description box below about the course. And now let's get back to the session.
So now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5 10 2 3, that means 10 5 15 and 2 3 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few flavors in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out a and b for you. Yeah, so see, A and B are 5 10 2 3, right? If we do a sum with x is 0, that means it will do you a column wise sum. So that means 5 2 7 10 3 13. Okay, and if you go for a row wise sum, then it will be x is equals 1, so it will return you 15 and 5, right? So that's how this will work. Okay, add a row wise sum, that's how it will work. Okay, so that's what is the so that's how this functions work. Yeah, that's how this numpy arrays are array sum function works. Okay, so that's how you can get the. Okay, give me a second. Yeah. Okay, fine. So this is not how it works, right?
Remove the
Okay, let
square
me.
bracket and keep only the circular brackets.
Sorry, no, not like that. It won't take it. Yeah, so x is 1 5 2 7 10 3 13. Yeah, got it. Okay, so two confusions were there. First of all, be like it like x is 1, why it is not taking up? Okay, let me check for some example in the ppt, doing some casual mistakes. Yeah, that's what I have written, right? So 0 0 0 1 0 5, so it should be 0 plus 1 5 plus 0, that is 1 and 5, so it's fine, right? 0 1 0 5, so 1 5. Yeah, correct. 0 0 1 5 6. Okay, let me copy this exact example what it does. np.sum with x is 1 having some problem. Just give me a few minutes, I will do that. Yeah, now it is working fine. 0. Yeah, now it's fine. So now if I replace it with a, I replace with b, if we remove this, as those are already list, how it works. Yeah, now it is looking good again. Okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem, I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So sum I will discuss it later. For subtract we already have discussed. For this division also, it will work in the same way. Okay, what is it with sum? Sure. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise, it will just take in two parameters and it will just divide to the numbers. Okay, row wise it will divide to the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay, similarly we can see the multiplication being worked on the same thing how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 1030, like that it will work. Okay, so these are a basic few functions that will be needed for our data science courses. And this expa, it will give you e to the power a. Sqrt, it is for square root. Np.sign is for sign value of each of the elements. Np.cos for cos value. Log for log values. Okay, so these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this numpy. I am showing that to you. So these are not really needed for being a data scientist, so you can just check these values. Okay, next is the element wise comparison. So we have, so that's how element wise comparison does. So it will compare each and every element of the array with another one and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you a output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np dot equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called, so it will give you a single value. Okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of false or true or false based on the comparison results. Okay, so that's how it is that's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now if if we have already seen this sum function, right? So
Arrays
np.sum.
are of different dimensions when you use equal, array equal, or other things.
Sorry, you mean this, right?
Yeah, so no, I mean when you're doing an equal comparison, yeah, so how did it handle different dimensions of the arrays?
It won't handle, right? It will throw you an error because that is how matrix works in real world, right? You
Okay.
can't compare, you can't add, you can't multiply matrices of different dimensions. It has to follow some rules,
Yep,
right?
agree. Yeah, I remember now.
Yeah, so same things will do it here. So for multiplication we have a rule, right? 2 by 1, if a matrix is 2 by 2, then the other matrix, the first one has to be equal to the second one of the first matrix, right? So 2 by 2 will go with 2 by 3, not with 3 by 2, like that.
Yes.
So those rules will apply here. Okay,
Yep, thank you.
that is what the basic things of this. Okay, so np dot mean max, these are there. Np dot mean. So mean, median, mode, standard deviation, this thing you guys remember? Because these are heavy terms that we are going to use for rest of our sessions. Too much. We will use this.
Statistics, yeah.
Yeah, basic stats. Data science is all about that, stats and maths. If you are good in these two, Python is super easy to learn. It won't take you much, and you just need to incorporate the thinking, that how do we think as a data scientist. So these three are main things. Others will fall into its place. But if you have a good base in maths and stats, it will help you a lot. Okay, so what is it? 4f. Okay, ff not. It's f. Come on. Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. I am forgetting this. If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array, so you can skip it safely. But again, that is a best practice. Write it. Okay. So np.sum a will give you sum of all the elements, minimum will give you minimum, max will give you the maximum element, mean will be the mean of the elements. Okay. So mean means the middle element of the arrays. Okay. Then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay. So that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay. So it will give you sum of all the elements, minimum of all the elements, max of all, mean of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not, let's not worry about it. So except this, have all these things clear. So that's how it will work. Okay. Okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine. Mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail. You can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay. Okay. So that is like broadcasting. Okay. What is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay. Yeah, axis won't work for this kind of cases. Yeah. Okay. So let's say we have this kind of an array to work with. So the first array, if you see, the first array is of two, I mean, 3 by 3, right? So 1, 2, 3, and 4, 5, 6. It is a 3 by 3 array, right? The second array, if you see carefully, we have passed 4, 5, 6, only 3, 4, 5, only 3 numbers. So that array comes to be of 1
This
by
2
3.
by 3, how is it 3 by 3?
Sorry?
You said the first array is 3 by 3, it is 2 by 3.
Oh yeah, correct. Thanks for correcting. Yeah, it's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3, 4, 5. Only 3 numbers are in there, so it is an 1 by 3, right? So now when you add it, if you notice it carefully, you will see the second row of the array is also getting added with the same number 3, 4, 5, right? So that's why it is coming 4, 3, 7, 5, 4, 9, 6, 5, 11. Okay, so how this is happening, this is the concept of array broadcasting in NumPy. Okay, so if you see in this diagram what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. I mean, this broadcasting is also done for the subtraction scenarios also. Okay, so this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to a integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and it prints accordingly, right? So let's say for this Monty Python, we are going from 6 to 10, so that will take from P till H, right? Because 10 will be excluded. But when we go for -1, then we go from the larger number to smaller number, because as you know, for negative everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do a 6:10, that means that is from 6 till 10, like that indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1 2 3 4 5 6 and 7 8 9, if you go for A0, then it will print all the elements of the first row. And if you, so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking, okay, so these two things returns basically the same thing. Okay, so when we have A0, we return the first element of, I mean, the first row of the matrix. Okay, when we return A:1, what does that mean? Okay, so :1 is for the I mean, so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write :1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1 2 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and I mean list of lists. And the first one of A0, we are just simply accessing the first element of the first row of the array, first row of the 3D array, I mean sorry 2D array, and that's why we are getting 1 2 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see how what all things we can do. So A:1, extract till row equals 0. That means it is the first row that is being printed, right? Now for the second part, if you remember the indexing and slicing thing, So the first one will account for the row and second one will account for the columns, right? So if we do :1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1: that means give me all from the first column till last. Okay. So that's where we get this 1: will return you 2, 3. Okay. Now if you remove :1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2, 3, 5, 6, 8, 9. Okay, so that's how indexing and slicing works for NumPy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So I will leave it up to you. You would need to answer this. Okay, so let me explain. This 2: means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only one row will get printed out, and we are giving :3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why :3 returns you 7, 8, 9. Now let me change it and see how many of you can answer. If we do it like this, what will be the answer? :2, then 2 colon. For row it is :2, and for column it is 2 colon. So y3, y6 separately. Okay. So for row we have given :2, right? That means we want the second row, right? So :2, that means we want till the second row. So the first two row will come into picture, 1, 2, 3 and 4, 5, 6, right? Then we have given 2 colon, that means third element onwards. So 3, 6, right?
Just a quick information, guys. If you guys are interested in mastering Python, make sure you check out Intellipaat's Python certification course. This will help you master the language and let you get in-depth experience about it as well. For details, check out the description box below about the course. And now let's get back to the session.
Okay, next thing is array manipulation. Okay, array manipulation is to stacking arrays. I mean, like, okay, so what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on two arrays and we are outputting a third array. Here also, we will almost do the same thing, but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so okay, the first function is concat. Okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally, and one is out of bound. It shouldn't be. Okay, we don't have any columns in here, right? So that's why column wise is not possible. But if we had 2D arrays, it will be possible. That's what I will create for you. It will be easier for you to understand. Yeah, so this is like column wise stacking, right? So this 1, 2, 3 in here and this 3, 4, 5 in here got concatenated together, formed a new row. This 4, 5, 6 and 5, 6, 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that, I mean, sorry, this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, let me print this matrices for you. It will be easier. So see, the first matrix is 1, 2, 3. Second one is 4, 5, 6. When we do row wise concatenation, right? We just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay. Now if we go for column wise addition, column wise concatenation, then what it will do, it will concat the columns on its own. Okay, it will concat the columns on its own. Okay, so then it will give you a new row output. Okay, so that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in because this is column wise now. So that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay, So that's how the array output will look like. So the columns will be concatenated to a row. Okay, so that's how this concatenation works. Okay, that's how the concatenation works. Okay, so this is what is about this concatenation property. Okay, next is vstack and hstack for numpy arrays. Okay, so what is vstack and what is hstack? As the name suggests, vstack is vertical stacking, okay, and hstack is horizontal stacking. Stacking means the same thing as concatenation with a with just a small difference, okay, that we will discuss now. So before going into vstack, what I will do, I will show you stack example. Okay, there is another function called stack in numpy. Okay, so I will show that first, okay, before going into this normal thing, this hstack and vstack operations. Okay, so what it will do for these two arrays only I will consider. So let's say I am stacking a and b with x is 0. So I am stacking a and b on x is 0. Okay, so it is not a list I should pass, it should be a tuple in here. Was what is happening? Okay. Sorry. This one is there, this one is here. Yeah. So this is how the stacking looks like. Okay. This is stacking horizontally. Okay. And if I go to x1, this is stacking vertically. Why the array is not changing at all? Have I changed it? No, right?
It is changed, Abhishek, for the axis one.
Is it? Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1 2 3 4 5 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, now I'm having some kind of a problem in
No,
here.
you're
Not
not
sure.
running it again. You need to run it again.
Yeah, I ran it, but still it is not working. Not sure why.
It's
But this
working
is not
for us.
returning in the proper stack also. This is not how it should return. That is again a problem. Let me try with 1D array once. 1 second. Yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay, so in horizontal stacking we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see in the row equals 0, the output is 1 2 3 and 3 4 columns. So the two 1D arrays have gotten into a sequence, row wise they have concatenated, but when it is going for column wise, then for 1D arrays it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay, this stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. Okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created, I mean, stacked array of its own, like of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay. Now here on the contrary, if you see the H stack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this H stack and V stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is okay, let me write it. So let me do it a bit clearly, give me a few minutes. Print vertical concat vertical stack. Okay, let's see the differences. Okay, now axis 0, axis 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1 2 3 2 3 4 concatenated in a same row, 4 5 6 5 6 7 concatenated in a same row. Okay, and return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row, and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased, and those elements are stacked into the columns. So 2 5 3 6 4 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things and these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for H stack, V stack, and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a mixed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like, I will show you. Stack, forget about it, it won't work here. So this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4 are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4, 5, 6 and 5, 6, 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we are concatenating the rows to the entire matrix. So 2, 3, 4, 5, 6, 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked in the rows at the bottom of the older matrix. Okay, for vertical stacking it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about this 4 operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides. So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking and there. Okay, that is how it works. So that is not much used, column stack function. Pardon please. So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, I'll show you here. The syntax how it tells is, for this split function is np dot split. Okay, it takes 3 parameters into account. First one will be a array, it can be anything. Next one will be index, this I will explain. The next one is axis. Okay, the array, the first one can be any numpy array. Okay, it can be any numpy array. Indices has two forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be, that array will be splitted from that row. Okay, splitted from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is axis, as you already know, that is having 0 and 1. That is the same thing as you already know, 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this a array. Okay, so print a, this will be our a array. Now what we will do, we will split this array. So a, the first, second one I am passing an integer, third one I am giving it a column. So see what happened, I provided 2 as an integer value, right? So the array is split onto two arrays. Okay, if I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay, why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here, so we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits, so the two arrays will be coming out. Now we are splitting it based on x is equals 1, so that means a columnar way. So we have 3 columns, so it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. critical thing is coming up for you guys. Now let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay, so this is how it will differ when you pass this, like when you pass this, pass a list to the integer value. So the array here will be split into three parts. Okay, and then those three outputs will be given. Okay, so in the list, the first one is an the first thing refers to the column. So the array will first be split into a colon 1. Okay, then the array will be split between these two numbers, that is 1 colon 2. Then the array will split for the last number, that is, sorry, the array will split into the last number, that is 2 colon. Okay, so this three thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has three elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these three parts. That's how split works. Okay, so this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now if we go for column wise, you see something different, right? So what is this doing now? Here everything is given for only row, right? But here everything is done for column. Okay, so see, the first output is 1 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay, so now if you see carefully, these are the splits that you got in there. Okay, 1 4 2 5 and 3 6. Okay, these are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into three parts like this. Okay, and then you concat the output of these three separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split, and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is. What is the advantage of numpy over list? Okay, so this numpy arrays consumes less memory. How? We will see in the next few minutes. Next is, this is faster. We will see an example that how faster numpy arrays can be. And next is more convenient. As you see in list, you didn't had all these methods, right? Sum, min, max, median mode, this concat, h stack, v stack, this all these methods that we have discussed till now, we needed to write those on our own. We need to do this on our own, right? So these are the that's why numpy array is more convenient. And as a data science, and someone was talking about pandas. If you know about pandas already, or if you have read about somewhere, pandas array is all only based on numpy array itself. Okay, it is same thing. Okay, pandas array and numpy array will go hand in hand, you will see. Okay, so if you understand numpy array better, it will be easier, it will be cakewalk for the pandas part. Okay, so that is what is about this array part. Okay, that is what is about this numpy part. Without wasting time, I will go into an example first, then I will come to this one. Okay, example will be somewhere down there. Okay, this one. This is a quick example how it is advantageous based on memory space, and how it is advantageous based on its accessibility time. We are having time near equals 0. Sorry for that. Let me increase it. We have another 0, another 0. Okay. So see, here is the example for memory size. What we are doing, we are defining a list, right? Range function returns a list, right? We all know. So we have taken a list here. We are getting size of 1, that is 1, and we are multiplying with len of L, right? So 1 is an int, so it will be, so what is y1? Because L will return a range of range from 0 to 1000, right? L will return that. So 1 will be the element and it will be int. So that's why we have written 1 here and we have written len of L. So that means L has 1000 elements and it will take 28 byte for each element to store. From the list basic, you must know this. So that is why it is printing as 28,000. Okay, for that it is printing as 28,000. So for storing 1000 elements in a Python list takes up 28,000 bytes. Okay, whereas for a numpy array it takes up only 4000 bytes. Why is that difference? So as you know, a dot size is, what is a dot size? A dot size is the length of the array. A dot item size is size of the array stored in the memory itself. Okay, so size of the array stored in the memory. So that's what it gives us, 4000. So that is coming as 4000 bytes. So why is that difference? Okay, why is that difference? Why is this huge difference? Now let's go to this PPT. So see, for numpy array, how we store, we directly store the data into the pointer. So forget about this dimensions, right? Focus into this data. So this is a numpy array where we have a data head and the data head points to the data directly. Okay, data directly. So as you might have covered in the list basics, how lists are stored in Python is not directly. Lists are stored on some memory location and that memory location is returned to the list element. So that's why that is an mutable one, because you and tuple is an immutable one, right? Because in tuple you can change the value because it directly stores the it doesn't have the memory address of it. It is an immutable one. But in list you will have the memory address stored in it. So whenever you access some element, it is accessing the same memory location only, not the direct value. So again, that memory location will have a value. So for storing memory location, it will consider 2 bytes, and for this it will 14. So 14 by 2, 28 bytes for a single memory location it will have. Yeah, list will be having two step of data storage. So first one will be a pointer, second one will be a data. Okay, second one will be a data. And no, numpy is not immutable. Numpy is mutable. We have seen multiple examples, right? Numpy is not immutable. It is not because of this storage that is immutable or mutable. That's what is considered. It is due to some other features. This is just a language construct. So they have made tuple to be immutable, and tuple doesn't store it like this. Okay, numpy is not immutable. Numpy is based on list only, so it is totally immutable. But the storage of data is different. It stores the data directly. Okay, but for Python list it stores the data in a two ways. Okay, so 14 by 2, 28 bytes will be taken up for a single memory location. Okay, so that's why that's what you saw in the example also, right? In a programmatic example you have seen it. So that is how it is beneficial from the memory location. Okay, now if you see, we are doing some xyz operations, that is adding to list. First adding to list and second adding to numpy arrays, the same thing we are doing. Okay, so here we needed to pass it through a loop, right, for adding. But here we don't need to do that. We can do a clear matrix multiplication by a plus b, and then we are returning the time difference. If you see the time difference here for numpy, for a normal list is 0.005. Okay, but for numpy arrays it is 0.000999, something like that. That is too small, because when I was doing it for 10,000 for my machine and configuration, for 1000 actually it was not even coming something. It was coming in a zero value first, not for 1000. And see, even if you see, for thousand lists, 1000 values in list and 1 lakh values in numpy array, still numpy is somewhat faster than list, right? If I do a 1 lakh in both, you will see that real difference. You will see it is 41% faster than a numpy array. Okay, now if I just reduce a zero, it is coming in the range of zero. Okay, that's how lightning fast numpy array is, because in numpy array the access is direct, right? So that is just going into the location, fetching the data and doing the addition or multiplication or whatever you want to do it. So that is what is being done in Numpy arrays. Okay, that is what is done in Numpy arrays. So that
But one
is,
question, like without
yeah.
memory location, how it identifies actually in NumPy array?
In Numpy array, the object is directly stored in the memory location. Okay, I mean in the RAM, right? In the RAM, in a block, it is directly stored. So Numpy contains a data head that directly points to that memory location. Okay, but for Python, the items are stored in some other place, and the address of that place is stored in the Python's item head. Okay, so memory location is there for Numpy array, but the storage is direct. It is one level storage. Okay, it stores the data directly into the memory location. So it is like in your RAM, in a RAM cell, putting in a direct value instead of putting in another memory address in your RAM location. Okay, so and in that memory location you will find the value. So that's how it works. Okay, so that is what the difference between this Numpy storage and like a normal Python list storage. Okay, and for the,
And one more question: is it going to store it continuously in case of list and NumPy? How it stores? Is it going to store continuously, or in the list it will store randomly?
it will get the memory location from the address bus, right? Whatever it gets, it will try and store over there. So there might not be any other pattern, because RAM, it anyways, it won't contain lot of values, right? So it depends on the computer system, right? How it allocates the memory to the Python compiler, it will keep on storing like that. So you can't control how Python can't control how your system works, right? How the address bus or how the CPU works, it can't control that part, right? So it based on the entirely based on your system itself. Okay, so we can't really comment on that, how it will be stored. So when you run Python program, if you want to know the backend, what happens, a request goes into your CPU sees if what kind of request it is. If it's a write request or a read request, it takes in the request, it sends into the processor. The processor then processes the request with the help of all the hardwares and the RAMs and all the address buses and the data buses that the computer is connected to, and based on their addresses and their availability and all, it gets written into the location. Okay, it is not really Python doing it, it's ultimately runs into your CPU only. So that's why having a stronger core is always important for data scientists. Okay, like stronger I mean that processor actually, that's what. Okay, so that's how it works. Okay, so that's what is about this Numpy arrays.
So this brings us to the end of this video. If you have any comment, head down to the comment section below and leave a comment there, guys. We'll reach out to you immediately. And also make sure you subscribe to our channel to keep in track with the upcoming videos.